Well, I tried to swap the cameras around, but it was not working, so I guess we're just stuck with this other terrible camera right now. Which hasn't started yet. Oh, it's not yet. Let's see if this works. Actually, not. These night bot just checked out. Let's see. Well, where's the cameras? The YouTube Nightbot works. Maybe they're not both logged in somehow. I'm streaming for about another hour. I think I had it set up this last time. I don't know last time. I'll do this. That's probably better. Yes. It's probably better. I don't know what I'm going to do with the game today. First, I guess. The server has a slight problem. It says only responding with errors and processes inbound requests one at a time. When a connection is accepted, server state inside of the accept. Let's go over this real quick again. So it's bad to not block things up. TCP listener. So we're setting a async listener. And then we're just going to loop through and continuously check that listener. Setting socket equal to what's there. And then the connection lets us rewrite Redis frames instead of byte streams. Hash type is defined by Redis Redis. Connection use socket. Connection reframe awaits. Respond with error. So it's almost not errors. It processes inbound requests one at a time. When a connection is accepted, the server stays inside the accept loop block until the response is fully written to the socket. It stays inside the accept loop until it is fully written. We want our Redis server to process many concurrent requests. To do this, we need to add some concurrency. Concurrency and parallelism is not the same thing. Alternate between two tasks. You're working on both tasks concurrently, not in parallel. For qualified parallel, you would need two people, one dedicated to each task. One of the advantages of using Tokio is that asynchronous code allows you to work on many tasks concurrently, without having to work on them in parallel, using ordinary threads. Tokio can run many tasks concurrently on a single thread. Interesting. To process connections concurrently, a new task is spawned for each inbound connection. Connection is processed on the task. Accept loop becomes use net TCP listener. We're getting rid of TCP stream. TCP listener. A new task to process connections concurrently. A new task is spawned for each inbound connection. So we're looping, and then we're letting it spawn. So we're doing the same thing, except a new task. Okay, let's see. New task is spawned. Each. Then so socket is moved to the new task and process there. So Spawn. The new task is spawned from each inbound socket. Task is moved to socket is moved to the new task process today. So we're moving through, and then each time we're processing this up. Tokyo spawn. Museum. Hey, thanks for following. How's it going? Astrixel. Hey, a raid. It's my first raid, guys. Man, what a time for all my equipment to fail and you have to use the backups. How's it going? Hope you guys just had a good stream. Sorry about the Nightbot. I don't have the settings tweaked yet to be very chat friendly. Yeah, sorry about that. I gotta fix that. Put that on the list. Anyways, we're working on learning some Rust right now. I need to figure out how to build some web scrapers, and I started doing that, and then I heard Tokyo for the 10,000th time. Yeah, see you, Mr. Alton. Thanks for the raid. So yeah, I figured I would learn some Tokyo since it kept popping up everywhere. And so I'm just working through the tutorial right now. It's super helpful. I'm not like a software engineer or anything, so hopefully someone in the chat is just as confused as I am. I just started streaming like a week ago, so everything is super rough cut, but if you're into watching people be confused, then you're in the right place. Okay. So, where were we? Tasks. Tokyo task is an asynchronous green thread. They are created by passing an async block to Tokyo spawn. Tokyo spawn function returns a join handle, which the caller may use to interact with the spawned task. The async block may have a return value. The caller may obtain the return value using a wait to the join handle. Okay. So this is just an example. So it's saying async main is equal to the spawn. So this is the handle. Spawn function returns. So they're just explaining what this spawn thing does that we just did here. Because before this was just looping. So it wasn't being concurrent. It was just processing this and then waiting and then processing this. But now we're creating a spawn thread. Well, I guess it's the same thread, but we're spawning tasks concurrently. So they're just explaining what that's doing, I think. Do some async work, right? Do some other work. Okay, and then okay, that's cool. The handle gets saved here. So this work is like frozen, I guess, or at least depending how it comes to execute. And then you unwrap, and then you can print it out. This would probably throw an error, but depends what you do. So a waiting on join handle returns a result. Okay? When a task encounters an error during execution, the join handle will return an error. This happens when the task either panics or if the task is forcefully canceled by the runtime shutting down. Tasks are the unit of execution managed by the scheduler. Spawning the task submits it to the Tokio scheduler. This is like a built-in scheduler. If you guys haven't seen the tutorial for this, I think we're basically just building like a Redis something, which I think is a cache. I'm not really sure. It feels like that's what it is, but it's like a miniature version of Redis. And it's interesting because we're literally calling it, like they built it, and then we're calling from it to piece things together, and then we're filling in the gaps in reverse, which is like an interesting way to learn. Okay. Tasks in Tokyo are very lightweight. Under the hood, they receive only a single allocation of 64 bytes of memory. Allocations should feel free to spawn thousands, if not millions, of tasks. Okay. Static bound. So this is a lifetime? So this is a static lifetime. Got it. When you spawn a task on Tokyo runtime, its type must be static. This means that the spawn task must not contain any references to data owned outside the task. Right. The common misconception that static always means lives forever. It's not the case. Just because the value is static doesn't mean that you have a memory leak. It would be more common, but sometimes misconceptions. Okay. This will not compile. Why will this not compile? This is a vex. This is a spawn. So it was saying cannot contain any references to data owned outside the task. Yeah, so we're referencing V here. So this would need to be a closure. Is that right? Let's see. It's power here. Static lifetime means it outlives all other active lifetimes. It's basically owned. Diya, thanks for following. How's it going? And so all these follows just pushed me over my initial goal of 15 followers, so I'm going to be streaming for 15 hours on Saturday. What is spawning? It was just defined here. Let's see. Spawning. Yeah. Spawning, from my understanding, is it's like a branching of tasks. So it's like creating a different thing to wait for. Right. So here we spawn and then move the process to the spawn. It's sort of like a thread, but instead of being parallel, it's concurrent. This is what I've gotten from this. So you're saying static lifetime means it outlives all other lifetimes. It's basically borrowing. So it's like a borrowing. It's like if you want to borrow something, but with a lifetime instead of borrow. That makes sense. Okay, so let's look at this. This is better formatted in full screen. So async. Yeah. Okay. Yeah, spawn is creating a new task or thread in standard process and starting it. Yeah. Much better diction than what I did. Clearly understands it better than me. So they're going to explain this. It's happened because variables are not moved into async blocks, even though it says move here. the v vector remains owned by the main function. Current line borrows v, the Rust compiler. Hopefully explain this to us. So just fix, changing this to move. Oh yeah, it's because there's a move. Because they don't have a move, you have to put a move. That makes sense. Instruct the compiler to move v. Now the task on all of its data, making it static. A single piece of data must be accessible for more than one task concurrently. It must be shared using synchronization, primitives using arc. So this is atomic reference counter, if I recall, which makes sense. Note that the error message talks about the argument type outliving the static lifetime. This terminology can be really confusing because of the static lifetime lasts until the end of the program, so if it outlives it, why don't you have a memory leak? Example is that it is the type, not the value, that must outlive the static lifetime. Okay, so they're saying that it's not memory leak because it's not actually borrowed, it's just that that lifetime is expired because the type. The value may be destroyed before its type is no longer valid. Yeah. Okay. When we say that a value is static, all that means is that it would not be incorrect to keep the value around forever. This is important because the compiler is unable to reason about how long a newly spawned task stays around. Okay. So the only way it can be sure that the task doesn't live too long is to make sure that it can live forever. Okay. This might be like super boring for some of you, but I literally just finished the Rust book, so I just typed. It sounds super fun. Trying to dive in. The link in the info box above uses the terminology bounded by its static, rather than its type outlive static. Yeah. In the future, it won't be so bad because I'll just have already known this stuff. Yeah, it's for Tokio dots. This doc is not super long, I think. Like, we're already almost a third of the way through, and we just started it, so hopefully we'll get to some real stuff in a couple days. You should have seen me an hour ago. I was trying to figure out HTML, which I know nothing about. Actually, I think you did. Alvin, you were here. I had a terrible insensitive voice. Oh, I don't. Is that a compliment? Thanks. Yeah, you were here for the terrible HTML. You're a survivor. Right. The link in the info box, very good that. No, we did. The link in the info box above uses the terminology bounded by, which is similar. Okay. It's type outlive static, or the value is static for the generic type static. These all mean the same thing, and are different from annotated with static, as in ampersand static t. Okay. So, send about. Task spawned by Tokio spawn must implement send. Did we do that? Oh, I guess await or process implement send. No, await probably implement send. This allows the Tokio runtime to move tasks between threads while they're suspended at a await. I guess maybe it doesn't. Maybe I just don't understand what's happening right there. Tasks are sent when all data that is held across await calls is sent. Tasks are sent when all data that is held across await. Wait, do they mean sent here? Just a bit subtle. When await is called, the task yields back to the scheduler. The next time a task is executed, it resumes from the point it last yielded. To make this work, all state that is used after .await must be saved by the task. Okay. If the state is send, it can be moved across threads. Then the task itself can be moved across threads. Conversely, if state is not sent, then neither is the task. For example, this works. Okay, so we've got a task called yield now, and then standard RC. Okay, so respond. Scope forces RC to drop before wait. Okay, yeah, okay, so we just blocked it here to call it drop. Gotcha. So we're printing it within the spawn. RC is no longer used. It is not persisted in the task ULC scheduler. Gotcha. This does not. Okay, this is the counterexample where it's not being dropped, which makes sense. Attempting compiled snippets results in this. We'll discuss a special case of this error more depth in the next chapter. Not sent right here. I feel like it's good to see these errors because it's just like pattern matching at that point since the errors are so wonderful in Rust. It's like a less painful way of doing that. Okay. Are we about to actually do something here? Yeah, I think so. Okay. Store values. We will now implement the process function to handle incoming commands. So this, we'll use a hash map to store values. Set commands will insert into the hash map and the get values will load them. Additionally, we will use a loop to accept more than one command per connection. So set commands will insert into the hash map and get values will load them. Additionally, we will use a loop to accept more than one command per connection. Okay. Let's see if we can get this. That's worse. Okay. So what do we have to do here? It's got TCP stream. Do we not need the listener anymore? Guess not. Actually, that's the same. Not annotating this with Tokio anymore. That seems wrong. But who am I to judge this book? So clear that. And then async. Oh no, I'm dumb. Okay. We're just annotating process. Oops. Yeah, that was wrong. That was right. Kind of collection attachment. Okay. So async process. So we're going to import inside of the function. It's and set functions. I've never used a hash map in Rust, so that's okay. It's in collections, that makes sense. And then hash map is used to store data. Mutable hash map. And then connection provided by mini-redis handles parsing frames from the side. Someone just like got bodied outside. I think they're okay. Sound like a car or something. I don't know if you guys heard that. Okay, so mutable connection. This is the same thing we did. So, and it lets us read, like we said before, it lets us read frames instead of bytes because everything else is a byte stream. Okay. So this is going to be indented, but the rest of this, looks like the rest of this is gone. Yeah, so this becomes a while. So while at some frame, connection, reframe, wait the graph. This phone is really, I need to figure out something way out of everything. Yeah, so that's all there. And then response. Match. Interesting. So from frame, I feel like you've got to really have a good understanding of what frames are, because there's a lot of frame stuff. Like, I feel like it's just collecting bytes into like words, tokenizing sort of. From frame. Where are we getting frame? Frame is in the sum let, or the let sum. So the frame is equal to what we unwrapped, and then that's the input from frame, and then we unwrap that. Okay. So that's going to be equal to this match. So we're inside the match statement, and then so we have this set named I forget what this error was. Oh no, yeah, that's just part of match statement. Yeah, so if it matches the set command, we're going to insert anyways. So put that to a string. So the value is stored as a vec u8. Value dot vet. So if it's a set, then we insert as a string in a vector. A vector u8s. And now we know that it's u8s because they're frames, and frames are that size, I guess. frame simple. So we imported this at the top, but it's from the thing we're building basically. Okay, to frame. What is that? Okay, so the matches get, but what is command? Where is that coming from? What is C and D? Give me insert C and D. Is that C and D part of response? No. Response is getting assigned to. I guess I don't know what command is. Command is this. It's not being set anywhere. Is it being set in main? It's not maybe. Is it being set? No. I don't know. Let's keep going and find out. So if that's some so what command is command part of Tokio? No. Oops. This. Simple. So what they're sending is so we're getting the key. So we give the commands, get the key, db.get. And what is db? db is the hash map. So we're getting the key from the hash map. And the frame simple. Yeah, I'm just typing the wrong thing. Should be frame bulk. So frame bulk expects data to be of type bytes. This type will be converted later in the tutorial. For now, reference to vec of bytes is converted to bytes using into. Interesting. Value. Let's see. So we're converting the vector into bytes using into. After cloning value. I still don't know where. Things I don't know. What DB is? No, that's hash Okay. Command CMD. I don't know what that is. I don't see where that would be. Yes. Null. There's nulls. It's not supposed to be nulls. It's a frame null, I guess. I guess that's okay. Maybe. I guess we can just do this. Oops. Oops. Let's keep going. Yo. Pseudo maze. What's that mean? How's it going? We're doing some Rust. We're trying to figure out concurrency in Tokio and acquire this new superpower. Is it raining in your place? Yeah, it was storming earlier. Why? Is it raining at your place? Can you somehow tell that it's raining here? That'd be interesting. Yeah, it was, I live in Florida, and there's a hurricane in the Gulf apparently. So we had a big updraft earlier. Yeah, it's not so bad. I've lived in Florida my whole life, and I never really noticed the hurricanes until people start stockpiling water and generators and stuff. Hope everything's good. Yeah, everything's fine. It's really not that bad. People freak out a lot about it, but I mean, it's bad in some places. The stuff you see on the news is usually like a couple blocks or something. It's not as bad as like earthquakes or tornadoes even. Anyway, I live in Texas. I was talking about the freeze out. Yeah. That was crazy. I know some people that were in Texas when that was happening. It's like, man, if you don't die from the cold, you'll die from your power bill. So we're panicking as the exit condition, or as the exhaustive condition, and then write the response to the plan. So reference to the response, which was set from that match condition in the while map. Yeah, okay. So that's on, so because of that while, it's only going to execute when it's appropriate. At least it should. Sorry about that. Maybe unimplemented command. I guess I'm not supposed to know what command is, so that it does hit the unimplemented part. Maybe that's it. Power supply companies aren't handling anything good, even the heat right now. Yeah, I heard about that too. They're like cranking up people's thermometers or something. That's insane. If they did that here, there would be riots because AC is the only thing keeping Florida habitable. Yes. Now, start the server. Alright, we can finally do our card run. Let's use it. Oh, I'm in the wrong directory. We gotta go to the actual place. We somehow typed it wrong. Not found in the scope. Yeah, because I deleted that because I thought we didn't need it because we've done it. Alright. We need TCP listening. find collection instead. Right. The list of cards 30. Okay. 47. That's easier. The collection part, I don't know. So let's go to 30 or 47. It's in here. We didn't post something. See, I'm getting close to this. Let's see. So that's posed. That's self-contained. That's self-contained. I should close that one. And would you believe it? The compiler is right. Wonderful. I'll open some compiler. Okay. So that should work. What did I get wrong about the collection? Mini Redis collection, standard collection action. That I should have just been able to copy this. Collections, it's plural. Don't forget about that. Okay. Man. People love the compiler because it catches their like super complicated mistakes, but for me, it just it's like I can't even spell stuff correctly, so it's like a double win. Oh wow, got more. Oh, did I not save it or something? I totally did. Collections. Yeah. That's weird. Okay. Saying line 44, I need a semicolon. So let's go here. I need a semicolon here because it is around what's this around? It's around the let. Okay, yeah, so the let ends and then the while. Alright. What else? Not found in this scope. The response is not found in this scope. That's probably because it's simple, right? That's true. Unopposed delimiter. I wish you would just tell me all of these ones, but I guess I can't. Man, I didn't even close. I didn't close anything. Without my game address. Yeah, that's what I'm trying to do, man. It's gotta put the work in, right? I guess. Well, program stopped. Well, we used cargo init to write the bubble program. Yeah. It's funny. So line 48, it's expected. That's the wrong node. That's the wrong keystrokes. Okay. So here it's expecting another semicolon. Oh yeah, the whole thing. The whole thing. Oh yeah, I forgot. This is what I did. I deleted to the bottom of the page. So I forgot that I had nothing down there somehow. Okay. Alright. Dang it. I added a semicolon. Should not have added that. I tried to do something on my own without the compiler's help, without the help of the tutorial. I got blasted. Still isn't seeing this in scope, which is a totally different issue. It goes on like this. I was trying to write as much programming language as possible without Googling how to write hello world. So just looking to the doc of the language and just write hello world and some stuff. How did you figure out the exclamation point? Bang. Okay. My errors can now fit on a single page. Wonderful. So it's saying that response is not in the scope. But this should compile. This is like one of those things that says it doesn't compile, right? Yeah, it should work. What did I do wrong? That response. Did I spell it wrong? I spell response wrong all the time. And running components. Let's go to the document and see how it's no stack overflow. So that's interesting. Why did you do that? Is that like a challenge? You lose a bet or something? And just to explore stuff. That's cool. Well, I'm glad you found Rust. Rust is a bundle of joy. Not compile by Redis. This is not found in scope. Why is response not in scope? Not interested in learning new languages because I don't have any need of learning new languages. I think Rust would go great. What's your main? What do you? I assume you know some language pretty well. You are good to go. Python? Oh, okay, that's cool. For you to go from Python misses a lot of syntax that a lot of languages have, so it's cool that you were able to go from there to other ones. So let's see, what did I do wrong? Understand response. What is this? This goes here. So this is where you get in spots where you can sort of test things. I get to make real mistakes that aren't like insane, like an answer sheet. The first time we learned was seed in the first CS course I gave. Yeah, me too. And then I barely passed the class and tried to never take computer science again. Didn't know that you can code. So you're doing electrical engineering? That's cool. My electrical engineering class was also difficult. But there's a misconception in my major that those things never get used for what we do. So they didn't really try with us. Switch to CF, so I'm trying to go away. You switch to CF after you do programming much? Like outside of Python? Maybe I'm not understanding that right. It sounds like you would do more programming when you switch to CS. After taking that course. I see. I gotcha. Yeah, that makes sense. Yeah, computers are super scary if you've never ever touched them. Everything looks like Hacker Man. Switch to from ease, yes. Yeah, that's probably a good idea. I tried to convince, I actually was successful in convincing one of my peers to switch to CS. Um, she's the manager of our other team, so I don't think she regrets it. I don't know why this response time should be super easy, right? So, wow, let's let response equal. Is it because is it spelled the same? First of all, it's okay. You're interested. What you need is a post-bac degree in CS online Oregon State University. Oh, thanks. I didn't even know. I thought you were from the other one when I looked at your paper, but that makes sense. There were two on there. Cool. Do you like the school? 2 years. Yeah, my managers have been asking me to go back to school so I would work less. But so far I've said no. I mean, I think I've spent enough time on this. Let's see if we can find the answer. What do you response in that? Once you get back to school. Well, they want me to do something other than work myself into the ground. So I decided to start a stream. Doing the CS stuff. Yeah, I mean, I was working like 16 hours a day or something ridiculous. It's not healthy. It's also probably against some laws. Yeah, they were like forcing you, I think. Let's see. This is annoying. Where is the difference? Response. Man. I really gotta fix the formatting of these screens. I can't see. And you guys probably can't see it either. Let's see. How's that? Oh, that's so much better. Okay. Why is it not like that? I thought of doing an online this degree. Really tech to this degree, machine learning. Probably talk to you. Yeah, I mean, I don't know. I guess I just never understood because, like, aside from talking to peers and going to office hours, I don't see how I couldn't just learn that stuff online. You know, I guess the structure of the course is helpful. Yeah, my problem is not finding information that I need to learn. It's having time to do it, you know? But maybe I'm wrong, because the stuff you were showing me looked super cool. Way above my head. I should learn stuff maybe for a time. Yeah, that's what I don't want. I don't know. maybe some people can learn like that, but I found that I take a long time to learn things. Like I have to go through it pretty methodically. But once I know how to do it, it's pretty like it's in there, you know. I don't know if that makes sense. Um, okay, it says. Okay. What is different? What did I do wrong? Connection new. Connection refresh. It's gotta be in response command from frame. I wonder if I just. I can't even see it. There's stages to this where we can figure it out. If all else fails, we can just oops, that's the wrong direction. Okay. If all else fails, we can just toggle it and see where I have a problem. Shouldn't be on that part. Oops. Well, the program lasts for 2 years. We all remember. So you'll be taking 2 courses. I have a lot of time to observe everything, to knock cells and stuff. Yeah, that's true. I don't know. I guess I just don't put a lot of value on the degree. You know, it's like, what do? I get the degree and then I go try to get a job to work myself into the ground, like I'm already doing. I don't know. Not the degree. That's true. I don't know. There's also the thing where it's like I don't see how the courses could keep up with the pace of the field, you know, like the pace of machine learning changes like every 3 months. I would guarantee you that what you're doing is like 500. I guarantee you that what you're doing is like 500. Like what I'm doing now, or what I would be doing with deep learning, or machine learning. Yeah, but every paper says they're state of the art, you know. And that's what I'm saying. It was like the time that it takes to create the course like syllabus, state of the art has changed. But I guess they adjust for that. I don't know. I only have a little bachelor's degree. So I hear that school gets very different after that. But let's see if this runs. Alright, what did I do different then? Here's something interesting about ML. Yeah, please share. Okay, so this is running. And then what do they say to do? Run hello Redis. Run the example. Okay, well, I hope I set this up right. Redis. Tokio tutorial. You guys probably didn't see this. Let's see. If you understand the state of the art of last year, you can read any paper and understand any novel methods. I mean, maybe so far, but I mean, so if you understand transformers, well, that's just like the nature of how it's been so far, right? Like it's just they started with the big things, and then they realized they only needed these smaller inside parts. That doesn't always have to be true. Yeah, and I don't understand transformers, so maybe I just shouldn't do enough. Transformers are supposed to be simple. What did they say? They said run examples, Myris. Let's see. It said Myris. Let's see. Yeah, I'm getting all out of whack here. Okay, that's better. That's not what I did. Example. This one's not. It's not like art collection. It's from before. Not fine. Oh man, I need to go to sleep. All over the place. This got a while ago. I'm sure. Yeah, but in the field where you can play around with stuff, do the easy job. If you have a lot of frames that abstract stuff in the background, maybe some of this, a lot of this, not stuff. Yeah, it's true. Yeah. That's certainly true. Like, PyTorch is great. I love PyTorch. And also, like, Scikit-learn is also great. A wonderful API. Anyways, I was in the wrong place. So we're going to go to, what's it? I will type what it worked. Now we can do this. Hey, that worked. Now we just have to figure out what we did wrong. Got value from the server. We took a convex optimization course, which is 500 and I'll understand the reasons why this looks and lots of not parameters. Yeah, but do I need a course on that to be able to do that? Maybe. I mean, maybe. Like, at some point you have to stop going down the abstraction tree, right? Because your life would just run out. Yeah, there's a ton of online courses and stuff. I went through some stuff like that, but I don't think I've done one on machine learning. Not in a while, at least. So this is giving me result equals some binary world. Okay, so what did I do wrong here? Okay. No, it keeps doing it. Okay. taking an MS that will simplify the topic to you. You can ask for more explanation about them. Yeah. I was going to say, for sure. So, this, let's see what we did wrong. I just messed this up. What did we do? So, that's on top of it. Part of the Venn journey is Google. How do they do it? So dumb. Just tell me the keystrokes. Do, sure. Redo. Oh, it's right there. Yeah, it's not. I don't know how many times I've done that. So how did you get into, share means? Did you just decide, like, this looks sweet? I'm gonna do this. Fair enough. Oh, did you have your question? I was just asking how you got into machine learning. Sorry. That's cool. Okay. So let's see. Let's do it this way. This is probably easier. That one's the same. It's the same. Wait, command from program. What did I do wrong here? That's so weird. I can't talk to this. Advisor was teaching data structure course during my undergrad. Professor Tind introduced himself and research gave me a great presentation about solving ecology and how efficiency. Yeah, it's cool. Seeing having a good professor is great. I had some good professors. Having a bad professor is terrible. I'm sure you know that. What? Maybe it's just too late for me to understand this. Like, in the day. Wait. No, false alarm. Chrome connection. So wait. You can tell that I don't understand what's going on at all because I'm just going like letter by letter to try to figure this out. I'm out of moves. I don't know. I've got one that works and one that doesn't work. And they look exactly the same to me. And into back clone. Command is time to panic. I invited in to teach. Yeah, I've had teachers like that, but for undergrad it doesn't really matter because students are just there to be taught. That was great. Did I just copy and paste the same thing? Because there's no way this thing works and this one doesn't. That's gotta be what happened. It's embarrassing. Let's go back. Let's find out what we did wrong. I'm not giving up. I don't care how illogical it is. Oh. And then you have the professors that are both bad at research and bad at teaching. And you get them for every single class somehow. So this should be the correct thing. I should have known that this part's wrong. Yeah, it's curious, isn't it? It's a curious concept. Okay. So this is this. There's gotta be something different. We're in the right haystack this time. Okay. So we're in response. And insert command, insert string to vec. So okay. And if let. Okay. So frame bulk expects data to be of type bytes. Type will be converted. We need to store. Wait. Okay. That was the same still. Oh no. Oh no. Well, at least I'm sure these are different now. I'm sure they're different, and I don't know why. Socket. Wait. No. That's not it. Okay. If anyone sees why this is different, please let me know. So I'd love to move on. I can't until I correct my mistake. Branch command. Response, follow it. Insert key string to back. So set should be the same. Get if let some value equals to me get command key frame bulk value thrown into also long. Oh my gosh, maybe it's a main. But how could it be a main? It didn't even touch me. It didn't even touch me. I didn't touch me either. Alright, we're gonna do another sanity check. Because I'm losing it. Right. Okay. Yeah. So their thing works. Right. Yeah. It works so fast. Right. Help speed. Finally I could go faster. So their thing works. Which obviously should. Oh no. I think I lost my sheet because I closed it. That's another thing I need to add. I need to persist history across them. So okay. That's there. Let me add that to my list of this. Yeah, that's better. I would say. Now I'm pretty sure it's right. Nice. Yeah. Thanks everyone for hanging out, by the way. I'm probably going to be here like every weekday from 6 to 11 Eastern time. So 10 to 15 UTC. Why is this? Bottom works than top doesn't. I gotta be missing something here. If I wasn't streaming, I would probably just like go take a walk and come back and see progress. Wait. No. Dang. Please rain. Walking rain. Coming that. That's the other thing about Florida, is no one owns an umbrella. You don't carry umbrellas in Florida. You just get rained on. Because it rains sporadically. It could be, it rains while the sun's out. Like there's no cloud in the sky and it'll just rain. It's bizarre. Here. I'm gonna do that actually. I'm just gonna save a copy of this and then work in a different one and figure it out here. I think I'll be able to figure it out here. I've spent enough toil. Yes. pay control tool. So this and this main unit. Okay, so we should be able to move on with our things now. That's good. Order means 364 days per week. They need to refill one. Yeah, it doesn't rain all year like that. It's only during the summer. So if you ever want to go to Florida, there's exactly 2 weeks in January where it's beautiful. The rest of the time, it's just hot. Okay. I guess we're gonna get back to this for the next 15 minutes. Might as well keep moving. Shared state. Turn through. I wish I could dock this. I don't need this right now. Yeah. How big do I have to get for? Works. Man. Let's see. If people hang out for another 15 minutes, I'll be able to do my first ever raid. Pass the buck, you know? Shared love. Shared state. So far we have a key value server working, which is pretty sweet. It would be awesome for the project I'm working on to not be a database, because we have a timeline, and that would be more complicated than I think we'll be able to do. So, if you guys don't know, we're working on a project for a local charity organization in Orlando. They basically provide discounted food and services to people with like very low incomes. So like, I think the range is like, you know, homeless, like actually homeless, to like 1,200 or like 12,000 a year or something. Yeah, we're gonna try to do something with them. We normally volunteer in person every year, but with COVID, we had to reach out and see if we could do something digital. But yeah, it's like a little competition between our teams too. So we're trying to do the best we can. I have a tendency to overreach though, so we'll see if we can get it done in time. And that's why I'm learning Tokio, so we can try to get some web crawlers, try to script some APIs or APIs/scrape websites, which I know could be done very easily in something else, but you gotta use Rust, right? Fairs must be appeased. Yeah, so far we have a key value server working. It's a major flaw. State's not shared across connections. We'll fix that. So, yeah, it is pretty dope. I hope it works out. Most of the time, charity feels like you're not actually doing anything, but you know, building them some software and like, I mean, not software, but something with this technology that can actually save them a lot of time and effort for a long time going forward. It's going to be great. There are a couple of different ways to share state in Tokio. Guard the shared state with a mutex. Okay. Spawn a task to manage the state and use message passing to operate on it. I don't know why, but that rings a bell as a bad thing to do. Spawn a task to manage the state and use message passing to operate. Generally, you want to use the first approach for simple data, the second approach for things that require asynchronous work, such as I/O primitives. In this chapter, the shared state is a hash map, and the operations are insert and get. Either of these operations is asynchronous, so we are using mutex. So they're not asynchronous, which basically means you don't want to be switching back and forth between them. Like you have to do them separately. The later approach is covered in the next chapter. I guess it's just interesting, different ways to share states. Add bytes dependency. Instead of using VecU8, the mini Redis crate uses bytes from the bytes crate. Okay, yeah, so the mini Redis is like a Redis implementation that they're spoon feeding us to Tokio. The goal of bytes is to provide a robust byte array structure for network programming. The biggest feature it adds over VecU8 is shallow cloning. In other words, calling clone on a bytes instance does not copy the underlying data. Nice. Instead, a bytes instance is a reference counted handle to some underlying data. The byte type is roughly in arcvec-u8, but with some added capabilities. Okay, that's interesting. To depend on bytes, add the following to your cargo tunnel dependencies. What is this? It did, right? So I'd like to have them both open. I guess it doesn't matter to have them both open since we're not going to be here for much longer. So let's just and then we can add this. You can tell the service is just version 1 nonstop. Let's see if we can open it here. I get used to doing this. The buffers are full. We turned the arrow keys on our keyboard off with the vim config and set the left and right to buffer toggles, which is nice because we can go back and forth through our toggle pretty quickly. This is wrong. Video, my Reddits, and what's it? Not this. Join the source. Okay. Yeah, so now we can just go like this. Yeah, so if we need to add something, it's just click away. And we can go like, let's see, this to see everything in the buffer. It's pretty nice. Anyways, initialize the hash map. The hash map will be shared across many tasks, potentially many threads. To support this, it is wrapped in arcmutex. There's many tasks and potentially many threads. Okay, that's like pretty robust for something like this, doing a toy example. For convenience, add the following type alias after the use statement. Following type alias. I don't think I've ever seen that done that way. Which basically just means that it's not in the Rust book. So, it's a very cool experience. Interesting though. Okay. It's like an actual database. It's just tiny. Redis. Maybe this would all make sense if I knew what big boy Redis was. But I think it makes no sense so far. So we've got some strings and this byte type in a hash map, in a mutex, in an atomic reference counter, and that's all wrapped up into 2 characters, capital D, lowercase b. Yeah. That's just so great. There's like no wasted syntax. It punches you in the face if you do something wrong. So let's do this. Okay. Then update the main function to utilize the hash map and pass an atomic reference handle to the process function. Using arg allows the hash map to be referenced concurrently for many tasks. Interesting. Oh, because it would just tick and then tick and then tick, and it wouldn't flash. That's awesome. Potentially running on many threads. Throughout Tokio, the term handle is used to reference a value that provides access to some shared state. Okay. So this is what our main should look like. I'm missing a bunch of stuff. Because they put this down here for some reason. That was before. So let's see. We can. I don't have the thing in my vent config to I don't have anything in my vent config yet to move lines around, so we're just gonna have to do this the old-fashioned way. Our hash map, it's easy to listen, and the rest is new stuff. Weird thing. Arc, mutex. Interesting. It's interesting that they don't list everything. I'm pretty sure they want to pick this. Right down here, Tokio main, missing listener bind to the local port, wait and map. And then, yeah, we can print that we're listening. And what's going on? Listening to. And then database new text, new hash map, and then does this new change. So a new hash map and a new text and arc. And the loop is still the socket to the listener. And then it loops. And then the token spawn in the loop. The async loop. Got it. Wait, line. Accepted. Still know where we're at when it executes, I guess, instead of staring at a blinking cursor. Ah, this is different. Something had to be different. Removing the database, or processing the database as part of, okay, so I guess we're going to have to change the process function as well, because this won't run right now. It needs to take 2 arguments. So what are they planning? it's good to like try to make predictions about what's about to happen, so that if you're wrong, you can learn extra, squeeze a little extra learning juice out of there. So they're going to add this DB. So they have to. What is the DB doing? It's a hash map that can be mutated asynchronously. Are you planning to have the project public in the source code? I would like to. I haven't. It's on my list of things to do. I need to talk to the organizers. I mean, I work in healthcare, so they're super sensitive about personal data and the data that we have on the people they're serving is identified. So I don't know if they would be okay with that or not, but the rest of it I certainly can. It's just like the literal data part that I don't know if I would be able to, but maybe. When I was doing research, I found like very similar data that was taken on a national level. So there's a good chance, but okay. Well, I guess we'll leave it here and then catch up tomorrow. I'll be back on at 10 o'clock UTC, 6 o'clock my time, and then stream to 11 again. Gotta follow, and we're gonna go raid someone. This is exciting. Let's see. Let's move this to it. Come on. There we go. Let's move this to this later. Okay, there we go. Finally worked. So let's see. Anyone that's doing Rust, I guess I don't even know how to do this. How do we do this? Is there like a button? No, no. Maybe it's in theirs. Yeah, see it. I'm hoping that there's a button I push to send a raid when I get into their channel. So let's see. No, that's me. Whoops. What am I supposed to do? It's got a null. We don't deal with nulls. If anyone has suggestions, I'll take those too. This guy's doing a hack the box. That's cool enough. Hack the box is cool. How do we? I don't even know how to do this. Wait, call by the name of channel you wish to raid. Oh, okay. Where's this guy's channel? Oh, it's gone. CH3 Fez. How's that? Thanks. Alright, hope you guys have a good night, and I'll see you the next time around. I'll be here.